So let's continue with mixins. In JavaScript, we can look at inheriting from mixins to collect functionality through extensions. So we use the superclass to extend it. Each new class we define can have a superclass from which it can inherit methods and properties. Classes can also define their own properties and methods. We can leverage this fact to promote function reuse. So these classes, such as this new object that define their own properties and methods, promote function reuse. So it's another way of saying how the subclass allows to override and to extend the functionality of its superclass. Mixins allow objects to borrow or inherit functionality from them with minimal complexity. So another thing is that you might misconstrue this as a facade. You may think that it's that facade is what allows the superclass extension or what provides the superclass, but no, it actually contrasts the principle of a facade, which provide a minimal complexity. Here, when you're creating a class, you're basically creating a new overhead instead of creating that object. So for mixins, it is basically similar to the superclass of object-oriented programming such as Java and C++. And it allows that superclass to be inherited from by the subclasses. So, or the objects, so the subclass in this case is the objects that borrow or inherit functionality from them with minimal complexity. Thus, mixins are classes with attributes and methods that can be easily shared across several other classes. So again, the basically is a superclass that has the attributes and methods that can be shared with other objects or or classes or subclasses. So you're basically using an object-oriented programming in a JavaScript, which is like what we've said, it's not ideal, but in case like you'll need to use that, you'll have to use this type of pattern, a mixin or a class-oriented pattern. First, why pages and rhymes become optional. So here, let's just jump into TypeScript concept because it is related to this. So for example, here we define a const pom equals to a function with a ternary operator, which means that depending on the value or the member that you would define, this object will return different things. So there are two possible objects this variable can become. Possibility number one, name double image and then page 7, which is this. So ternary operator basically a union. So you're not requiring both, but one of them must be returned in order to use this object. So possibility to name her kind, comma, rhymes true. TypeScript sees this and says the variable pom could be either of these pages. So this pom or const pom, so as you can notice, this const pom is a variable, though it is const, starts with const. So it creates a union type A or type B. Second, the inferred type TypeScript creates. TypeScript infers something like this: name, string, pages, number, rhymes, optional, undefined. name, string, pages, optional, undefined, rhymes, boolean. So why? Because for property name, object 1 exists, object 2 exists. For property pages, for object 1 it exists, for object 2 it does not exist. For property rhymes, for object 1 it does not exist, for property rhymes, for object 1 does not exist, object 2 it exists. So TypeScript converts the missing ones into optional properties. Meaning, pages is number or undefined, and then rhymes is boolean or undefined. So third, the mental model that makes this easy. Think of it like two possible boxes. Box A, we have name and pages. Box B, name and rhymes. The variable could hold either box. So TypeScript says name, always there. Pages may be there. Rhymes may be there. So the final safe interpretation is pom.name is always safe. Pom.pages is maybe exist. So this po is the value of the object. So whenever we're trying to access an object, we always use this their value or the name that we use. And to access their member, we need or the key. We need to use the dot operator and then the corresponding key. Like poms.page maybe exists, pom.rhymes maybe exists. Fourth, why pom.pages becomes number or undefined. So when we use this pom.pages, the TypeScript will return as a number or undefined types, because TypeScript cannot guarantee which branch run. Example runtime cases. Case 1, name, the double image, comma, pages 7. Case 2, name, her kind rhymes true. So if TypeScript allowed pom.pages.toFix, it will crash in case 2. So TypeScript forces you to handle the possibility number or defined. So to be able to use that, you need to handle both of the types in order to avoid runtime crashes. Fifth, the proper way to handle it, type narrowing. You check if the property exists. If string pages in POM, open semi-curly bracket, console.log pom.pages, and then closing. Or if pom.pages is not equal undefined, console.log pom.pages, and then closing. Now TypeScript knows you are in the pages version. 6. Why the explicit union example forbid access? Later the book writes type pom equal pom with pages or pom with rhymes. Then pom.pages is error. So if we do an explicit union such as this, we create type aliases for this explicit union, and then when we call this, TypeScript will give us an error to avoid those runtime error we discussed earlier, to avoid using method available operation for that type. Why? Because TypeScript only allows accessing properties that exist on all members of the union. Like common property name, not common pages and rhyme. So it forces narrowing. So if you explicitly union it, just like with type narrowing, you're basically narrowing it into the common property. So all not common property will give you an error to make it explicit in runtime, and again to narrow the type. So it forces narrowing. We'll go deeper in this moving forward, but basically how this connects is that to mix-in pattern is that with mix-in pattern, you're basically reusing objects. Here you're reusing the types, right? You're avoiding the uncommon, and you're reusing the common. So 7, deep concept you just touched. You just encountered one of the ideas of TypeScript: structural typing plus union inference. TypeScript is constantly asking what shapes could this value possibly be. Then it creates the safest possible type. 8. Why this feels confusing at first? Because in JavaScript we think this object has pages. But TypeScript thinks this variable might have different shapes depending on runtime, so it protects you. The funny part, you're actually hitting intermediate TypeScript level concepts already, not beginner ones. Union types, optional properties, structural typing, type narrowing. Most React developers never learn this properly. Additionally, you unconsciously know or like understand how the functional programming work, because functional programming states that you can create a first class object, and then since TypeScript restrict types, it allows you to create like a function that could be an argument to another function, as long as you reuse the types, kind of like with mixing. You're reusing the function through classes. So first, the problem all system faces multiple possible shapes, or in mixins, multiple possible functions abstracted in the class. Earlier you saw this const pom equal mat.random function is greater than 0.5 ternary question, and then an object name colon string the double image comma pages colon 7, then closing object, and then colon, and then object again. Key is name with a value her kind string, and then rhymes with a value true. The system has two possible shapes. TypeScript says pom with pages or pom with rhymes. But then the problem appears. Pom.pages is error. Why? Because TypeScript cannot know which one it is. This is the same problem in many systems. Example, domain, React state, problem, loading or success or error. Domain API response, problem, success or failure. Domain WebSocket events, problem, join or leave or message. Domain UI state, problem, idle or loading or submitting. Domain LiveKit events, problem, participant connected, /truck subscribe. All of these are one object that could be different types. Okay, so this React state, it could be encapsulated in one object that has different types, such as this loading could be a string, success could be a number, etc. So second, the JavaScript pattern that solved this. Before TypeScript existed, JavaScript developers used a pattern. They added a tag property, example, in an object, member type with the value pages, member name, the double image, member pages with a 7 value, or another or for rhyme object, a type, member type with the value rhymes, member name with the value her kind, comma, and then member rhymes with the value true. The type property tell us what the shape object is. This is called tag union or discriminated union, which we will later describe, and then we will dig deeper on that in the future videos. Third, what TypeScript adds. TypeScript recognizes this pattern automatically. Like if we use type aliases, so we explicitly use this type pom with pages equal an object name, member name with the value string, member pages with the value number, member type with the value code pages, and then closing, and then type pom with rhymes equal object member name, value string, member rhymes, value boolean, member type, value rhymes. And then we have type pom equal pom with pages or pom with rhymes. Now TypeScript can narrow the type. Like if pom.type equal string pages, then inside you can return this, or you can call pom.pages. It's safe because the discriminant type tells TypeScript which shape it is. So if you are calling like a value with its member, as long as you're explicitly calling the shape, or TypeScript is not confused about the shape or type, it will allow you and it will not provide an error. Fourth, why this is actually a design pattern. This is basically a state pattern from JavaScript design patterns. You studied design patterns earlier. The system state is encoded in the object. Example request loading success error in TypeScript. Type request equal union vertical member object member status value loading, and then another object member status values string success comma member data value data, and then next union, and then object member status value error comma member error value string. Now the system cannot enter an invalid states. So these states are basically, it is related to how we use the behavior sharing and the prototype and the policy, right? So we basically distinguish the states. And another example of this, I think we will just about to discuss this in observer pattern and mediator pattern in behavior pattern, but we touch about this with state flags, behavior, and um, do you call this policy pattern. But I mean, a structure pattern can encapsulate all of this. As you can see, the reason why it's complicated, because a structure pattern that we are discussing now, which is mixin, could encapsulate this actual logic or behavior or the state machines that we are discussing. So this is exactly what React state machine use. In React, you often see message state like this: cons parameter loading comma set loading equal use state parameter false, then cons data comma set data equal use state parameter null, next cons error comma set error equal use state parameter null. This is dangerous. Possible states: loading to error, data to loading, error to data. These are invalid states. Discriminated unions, or the one we had with JavaScript before that explicitly describe the type, fix this. So for example, we can also do that one with TypeScript, like type fetch state equal union member state with a value loading, and the next object union again member state value success comma member data value user, and then union again with an object member state value error comma member error comma value string. Now React state becomes const parameter state comma set state equal use state parameter fetch state function. Now rendering becomes clean. If state equal string loading, return spinner. Then if state equal error, return error. Error, I mean the one being returned here, error slash, I mean less than error slash greater than error, which is kind of like the HTML. And then if state equal success, return the HTML profile closing. Now again, as you notice, the pattern as well with React is that whenever it creates a if, the logical operator, I mean, is enclosed in parentheses, like state equal string success. This is massively safer architecture. 6. This is also used in backend event systems like LiveKit. Real-time systems like LiveKit handle many event types. Example events: participant connected, participant disconnected, track published, track subscribe. Internally, they look like type LiveKit. So type member type, I mean union again, member type value participant connected comma member participant value participant, so and so on. Okay, so then the system process them safely. Switch parameter event that time open semi-curly, then case participant connected, then a handle participant function or a parameter event that participant, then break, and then case track publish colon, the next line handle track parameter event that track, then closing. The type field is the discriminant. 7. This is also the same as message queues. Kafka, RabbitMQ, Web Socket Events, Redux Actions all use the same pattern. Example in Redux: type action equal union object parameter type key parameter key type, sorry, member type value add to underscore to do comma member value the actual member payload, value to do, and the next union again, type, and then so on. So for reducer, it's switch operation, switch parameter action that type, open semi-curly, next line case, add underscore to do, and so on. This is discriminated unions in disguise. 8 intersection types equal combining capability. Now look at this part, type written art equal artwork plus writing. Intersection means must satisfy both. So the object becomes genre, names, pages. This is similar to composition in JavaScript. Instead of inheritance, class writing artwork extends writing. We combine capabilities, artwork plus writing. This is basically composition over inheritance. So instead of like extending, like creating the class, okay, instead of using mixins that we are talking about in this structural pattern, we actually are using this intersection type or combining capabilities to more efficiently handle these classes. So instead of extending it like this with a classic object, we combine the capabilities such as artwork plus writing. So this is basically composition over inheritance. So that's what we use when we do a type aliases, type written art equal artwork and writing in intersection types concept in object types in TypeScript. So why never exists? This part, type not possible equal number and string, means value must be both number and string, which is impossible. So TypeScript returns never, meaning no possible values. This is useful for exhaustive checks. Example, function handle, parameter pom colon capital pom, then inside is a switch parameter pom dot type open semi-curly bracket case string pages colon then break, then case string rhymes colon then break, then default colon then const impossible colon never equal pom. If you add a new type later, type colon string song, TypeScript forces you to handle it. This prevents entire classes of production bugs. Thent, why this suddenly click for you? Earlier you said something very important. All those concepts are needed for me to grasp it internally. You studied OS, networking, design pattern, system architecture, JS fundamentals. Those create the mental scaffolding. Now when you when you see TypeScript types, your brain maps them to system states, message protocols, event types, object composition. So the concept becomes intuitive instead of memorized. 11. The deep truth. Discriminated unions are basically TypeScript encoding a system state machines, like state machine, and then at the bottom of it is the tag union, and then the discriminated union. This is why many engineers say discriminated unions are TypeScript's most powerful feature, because they allow modeling real systems safely. And interesting part is this, your learning path, OS to networks to design patterns to JS to frameworks, is almost identical to how senior engineers understand systems. So let's go back to mixins. So you didn't misunderstand syntax, you misunderstand what inheritance is trying to model. Right now your brain thinks, if mixins let me reuse behavior from many places, why can't a class just inherit from many parents? It can't, because like we've mentioned in prototype, JavaScript is a linked list. It references other node. It can't just reference multiple nodes, or it can't just connect to multiple nodes. You need to traverse those nodes in the linked list. So the question has confused many programmers for 40 years, and the answer is deep. It connects why JavaScript prototype system exists, why TypeScript pushes composition, and why your LiveKit policies naturally emerge. Let's rebuild the mental model carefully. First, the hidden assumption breaking your understanding. You're assuming inheritance is a code reuse mechanism. This is the core error. Inheritance was never invented for code reuse. Inheritance was invented for classification of reality. In classic OOP, like Java, a class hierarchy means animal to mammal to dog. This is not about sharing functions, it's making a statement, a dog is a mammal. This is called the is-a relationship. A dog is an animal, a car is a vehicle. Inheritance models ontology, what something is, not capability. And this is exactly where multiple inheritance explodes. So like a multiple inheritance models what something is, not capability. So it's hard to model like a complex object, and JavaScript is more suitable than that. So why multiple inheritance breaks reality? The diamond problem. Imagine person is an employee and also a student, and a student could be also a working student, and employee could be a working student. Now person has ID, employee has salary, student has ID number in database. Which ID should working student have? First, people, a person that walk function, employee that walk function, different implementation, student that walk, different implementation. Which walk function is correct? This is not a coding problem, this is a logical contradiction. Multiple inheritance is trying to say one object is fully two different things at the same time. But in real systems, objects rarely fit clean taxonomies. Your live kit example, if a doctor is a user, yes. If is a doctor is a doctor a user, yes. Is a doctor participant, yes. Is a doctor a moderator? Sometimes. Is a doctor an admin? Sometimes. You cannot model this cleanly as a tree. Reality is not a tree. Reality is a set of capabilities. This is the moment programmers historically discovered classification hierarchies fall for complex systems. Third, what mixins actually are. Mixins are invented as the escape hatch. They change modeling question from what is this object to what can this object do. This is a massive shift. Inheritance to identity, mixin to capability. So instead of doctor extends user extend person, you model doctor can authenticate, join room, send message, moderate. These are capabilities. This is exactly what your code can authenticate, can join room, can send message, can moderate. Naturally become you accidentally discovered capability-based design. Why JavaScript forbids multiple superclasses but allow mixins? Because JavaScript learned from C++ mistakes. JavaScript prototype system does something subtle. It allows one identity chain but many behavior sources. So because it linked list, it won't be able to do as what it is done in superclass, subclass pattern, but it can allow one identity chain that has many connected behavior. Why? Because identity must be ambiguous. An object cannot simultaneously be two unrelated base entities, but it can have many abilities. So JS enforces one prototype chain identity, many composed behaviors capability. So mixin is different in that sense with a classic superclass and subclass. So mixins are not real parents, they are behavior injection. So think about this like a singleton or dependency injection, in which you inject the database connection from environment configuration to a component for them to be able to access the database. It's the same here, but it's called behavior injection. You're not calling it superclass to subclass pattern or classes pattern or state pattern. They do not say you are another type, they say you gain a skill. This avoids diamond paradox. How this connects to our previous discussion. Now everything we discuss align, concept singleton, what it controls, existence, how many, concept factory, what it controls, creation, how made, concept prototype, what it controls, memory sharing, where methods live, concept mixin, what it controls, capability, what can it do, concept policy, what it controls, permission, what is allowed, concept facade, what it controls, complexity exposure, how accessed. You were blending mixin with prototype earlier. Now the real difference, prototype equal memory model, mixin is equal architectural modeling. So again, this go back to how this structure, or now let's say it in another word, or an architecture model the whole system rather than the exact memory model or exact modeling of how each component will work. So prototype happens even if you write zero patterns, because this is how your system is Mixin is a deliberate design choice. So prototype, again, because this is just how JavaScript works, mixin is how you would structure the whole system and how you would connect all the code. That's why it's kind of like hard to see whenever we're discussing the types and the classes and how it relates to the function reuse and the composition inheritance. So where your understanding is hand wavy, you often equate sharing behavior equal inheritance. Not true. There are actually three completely different sharing mechanisms. First, prototype sharing, same function in RAM. Second, mix-in sharing, same ability. So prototype sharing, basically, this is what JavaScript does. You have those like provided RAM or virtual memory to your process, and then if those like components share the same memory, they will use the same RAM. So you don't need to like access it in disk. With mixing sharing, you're basically declaring a same ability throughout the whole architecture. For policy sharing, it's the same rules. Your LiveKit app mostly use number 2 and 3. Very little of your architecture depends on inheritance. This is modern backend or front-end architecture. Your biggest omission, important. You still think OOP models objects. Modern software does not model objects. It models actors interacting under rules. Your system is actually actors. Okay, again, that's worth reiterating. Modern software models actors interacting under rules. So actors, patient, doctor, system. Capabilities, we have join room, message, transcribe, admit. So that's actually your LiveKit. You don't just have like a user identity in database. We have patient, the doctor, and the system. That's my actor. Capabilities like joining a room, messaging, transcribing the thing, admitting. Rules, doctor can admit, patient cannot admit, moderator can mute. So this is not OOP, that is domain modeling plus policy system, and this is exactly where your brain naturally moved to. Contracts.ts, service-core.ts, policy.ts. You weren't writing classes anymore, you were writing a domain model. 8. The subtle misunderstanding that will block advanced topics. Here it is. You still think patterns are features of a programming language. They are not. Patterns are responses to pressure in system complexity. Languages just offer tools, prototype to language mechanism, mixing to architectural technique, policy to system design, facade to interface design. So architecture technique is mixing, policy system design. The prototype is the built-in JavaScript language mechanism, and a facade is an interface design. So if you keep tying patterns to syntax like class extends objects, advanced topics like distributed systems, event sourcing, CQRS, microservices, authorization engines will feel confusing because those operate at a level about code structure. So it's not about the like language mechanism or the code structure or how it code or language will define the code like class extends object. It's about the higher level abstraction or layer or above code structure. So 9, the clean mental model to keep. Instead of remembering details, remember this: a software system has 4 separate concerns. First, existence, how many things exist, singleton. Second, creation, how they appear, factory. Third, capability, what they can do, mixing. Fourth, permission, what they're allowed to do, policy. Your LiveKit telehealth app is almost entirely capability plus permission architecture, which is exactly why classical inheritance started feeling in your head. Your intuition was correct, your model wasn't wrong. It was outgrowing class hierarchies.